So let's take a look at our first page of our final review. So one thing about trig is, I know at the end it got a little bit on the tough side, but keep in mind your final exam does go over the entire semester, all the way from the most basic to the most advanced. So we're going to start off page 1. I'm just going to go ahead and do this series of videos, one page at a time, however much time it takes to go through each page. But I think page 1 should be a pretty easy one. So let's see how we can do on that. So off we go to the very beginning, which of course an integral part of trig is looking at our friend the unit circle here. So when we set this up, remember that this would be 0 degrees, this would be 30 degrees, 60, and, oh, whoops, I missed one. This would be 45, 60, and 90, right? 45, 60, and 90. Those are the big angles that we're interested in as part of our unit circle. Remember that 0 degrees would be 0 radians. 30 degrees would be pi over 6 radians. Hopefully we have these things memorized well by now. We've got pi over 4 kicking out the 45. Pi over 3 being our 60-degree angle, and of course pi over 2 our last one. Now, keeping in mind this is our unit circle, that means we're going to be moving to the right exactly 1 unit. So that would be the coordinate 1, 0. And in that same way, that tells me that if we went up here, this would be the coordinate 0, 1. And so we're just going to quickly go through our first quadrant, and keep in mind as we move this way, the y values are going to get taller and taller and taller. And we've talked about how you start with 0 and you start counting. There's 1. There's 2, there's 3, and we also hopefully remember that we take the square root of these values and divide everybody by 2. And then as far as the other values go, remember these values that we have done so far, these are going to be our signs. Each of these things is going to be the sign. I'm going to put that in orange right here. Remember our y values are the sign. And our x values are going to be the cosines. I'll put that right here in blue. But they're basically the same idea, just in reverse. So this would be 4, 3, 2, 1. And remember, we take square roots and we divide by 2. And these would be the cosines as we work our way through. Meaning, as we talk about that, that means that the cosine of pi over 6 would be root 3 over 2. The sine of pi over 4 would be root 2 over 2 right there. I think I said that wrong. The cosine of pi over 6 would be root 3 over 2. Here, the sine of 90 degrees would be 1, and the cosine of 90 degrees would be 0. So here we go. So we're going to go through our process and label a few things up, a little bit of simple unit circle. So we should know, I'm going to go through some of the values here. And we also have the ability to do this through a grid, and we've done that in as well. And so sometimes people like that a little bit better. So maybe I'll put this down at the bottom. So we could either use what I have up at the top of the paper or sine, cosine, tangent down here. And we could come through our main angles. 0, 30, 45, 60, and 90 degrees. We could do our count 0, 1, 2, 3, 4, and then 4, 3, 2, 1, 0. And then, of course, my last little piece, I didn't line those up well. My pi over 3 should be here, and my pi over 2 should be here because I kind of split everything over too much. And then, of course, my tangent is really a sine over cosine. So remember, sine over cosine, that's 0, 1, undefined, root 3, and root 3 over 3. You've seen me do that a few times. I always do that in a strange order because it's just what works for me. So this is actually my friendly spot. That's what I like to do, think this way, because then I think of all my ratios lined up nicely. And so I know that the tangent of any kind of pi over 3 should be root 3. So if I go up to here, this was not a tangent. It was a cotangent, so it's the reciprocal. So the tangent was root 3, so the cotangent is going to be 1 over root 3, also known as root 3 over 3. The only problem that we have is to decide what quadrant it's in. So if I were to rotate backwards 3 pi over 3, rotate backwards 6 pi over 3, and I have to keep going just a little bit further. My mnemonic device was all students take calculus or a stupid trig class. Last time you'll probably hear me say that. And so I know that this is the location where I'm looking for cosines that are positive. That means the tangents and cotangents are therefore negative. So we are done with that problem. Now keep in mind that because we are taking a final and we want to make sure that we're right, it wouldn't be a bad idea to check our calculator out and say, okay, I'm in radians, so I'm going to do that. And I'm going to take 1 divided by a tangent because, again, it's a cotangent. And I'm going to ask for -7 pi over 3. Now, I'm hoping that's the right answer. And so I could check my square root of 3 over 3. And I didn't put the negative in, but you can see that that's the right value, that root 3 over 3 is, in fact, that 0.577 that I've got. And I could do the same thing on each of these other problems. See, the cosine of -9 pi over 2 is, well, it's giving me a weird answer. That's a calculator speak for the number 0. So I know this answer is 0, but that makes sense because, again, if we look down at either one of these things, the cosine of any kind of pi over 2 is the x value, which is 0. Or I could look down here at this list at the bottom and say that the cosine of any kind of pi over 2 is 0. And clearly, I don't need to adjust positives and negatives on the number 0, so 0 is good. Now, 28 pi is interesting. That actually works its way around a circle 14 times, because remember, 2 pi is a full circle. And 28 pi is just 14 of those full circles. So if I go around the circle 14 times, I'm going to land right here at the coordinate 1, 0. So you want to remember that the cosine is always the x value, and a secant is just the x value flipped over. So if I found the cosine, which is 1, and I took its reciprocal, I would get 1. And then we just have to stop and think, is it positive or negative? But, you know, as we did it, we went around the circle 14 times facing the right. So it's clearly a positive value because it's facing the right. Now, if it had been 27 pi, it would have been facing the left and I would have made it negative, but it was facing the right. Tangent of 11 pi over 4, again, you could either look up here and know that the tangent is the y over the x, or we could look at our grid down at the bottom and know that the tangent of any kind of pi over 4 is right here. So we know it's either 1 or -1 based on the information that we have. So let's go ahead and bring that up. We know it's the number 1. And I just have to think that this would be, again, we're going to count by 4s. So this would be 4 pi over 4. This would be 8 pi over 4. I didn't quite make it to 12 pi over 4. So I stopped in the third quadrant, just shy of 12. So ASTC, it's not in the tangent quadrant, so therefore we're going to assign that a negative. But again, it wouldn't be such a bad idea to validate my response and look at it and see, in fact, it was negative like I intended. Okay, so last one of these things, and we're done with the unit circle. I know that according to my grid, and it's right here, the sine of any kind of pi over 6 is a half. This is telling me to rotate backwards. So let's see, that would be -6, -12, not quite -18. So it's down here in the quadrant, and that's not where the sign should be. Remember, ASTC. So it should be a negative answer because it's in the wrong quadrant, but there's a negative sitting in front. So we're going to flip that sign over, and we've got, again, a positive. But it would be silly if you have a calculator in front of you not to ask the question. So we've got -17 pi over 6. And my calculator, I put the negative in here, I put the negative in here. It's going to handle that perfectly fine and say, hey, you got a half. Okay? Now, moving on a little bit, away from the unit circle, just thinking about stuff, let's figure out what happens if we want to take these things that are in degrees and go to radians. Now, our happy little converter is we take 495 degrees, and the way you go from degrees to radians is you put 180 degrees in the bottom and pi on top. Now, I'm a little bit lazy, so I'm just going to go ahead and take my calculator because I know that this 495 and this 180 can reduce. I mean, clearly they're both divisible by 5, but there might be a little bit more. So I'm going to let my calculator do it because I don't want to. And I got 11 quarters. So that means in radians, I would have 11 pi over 4. But this also asks me to find a single angle that is equivalent to it, but it is coterminal. So keep in mind, anytime you spin a circle, either forward or backwards, you're going to end in the same place that you were. So remember, a circle is 2 pi radians, or 8 pi over 4. So if I could either move forward 8 pi radians over 4 or backwards, that would work. So the easiest answer would be 3 pi over 4. But some of you guys might want to include, you could have said 19 pi over 4. There's an infinite number of answers by either adding successively or subtracting successively values of 8 pi over 4. So off to the next one. 780 times pi over 180. We're going to do that again. So 780 divided by 180, clearly both divisible by 10, but I think there's probably more. So I got 13 pi over 3. So similar to this problem, 2 pi in thirds would be 6 pi. So if I go forward or backwards 6 pi, I think I would go to 7 pi over 3. Or I might go to 1 pi over 3. There's an infinite number of answers that work. I could say negative 5 pi over 3, whatever I want to do. And my last one of those, 130, this one is actually a little bit easier. I know that if I divide by 10, 13 is a prime number, so I'm not going to get any more action on that one. And so if I wanted to rotate, again, using 18, 2 pi would be 36 pi over 18, because that would be 2 pi in reduction. So I could either go forward that far, which would get me to 49, or some of you would choose to go backwards 36 and get to negative 23. And that would work well. Now, of course, going the other direction is pretty much the same idea. We're going to take 13 pi over 12, but instead of multiplying it by pi over 180, we're going to multiply by 180 over pi. Notice the pi's are going to cancel. And let's see, that would be 13 times 180 divided by 12. And I could do this by hand. I could think through the reduction. I'm just trying to be a little bit quick and lazy. And I've got 195 degrees, right? So again, in degrees, instead of thinking about 2 pi, we're just going to think about adding and subtracting 360 degrees. So a nice coterminal angle would be, I could go negative 165. That would work. Or if I started off with 195 and I added 360, I'd have 555. Either one of those answers is valid, and I can keep adding and subtracting. I can just keep going like this. All of these numbers, let's see, let's add 360 to that. Every time I add 360, all of these things are going to be coterminal values with the one that I gave you. It would be silly to write any of those numbers, to be honest, but they're all valid answers because it just says, give me one. And so the last one of those, 8 pi over 9, let's multiply by pi on the bottom, 180 on top, because we're getting into degrees. So we're going to take 8 times 180 divided by 9. But before I do, I know that 9 goes into 180 20 times. So it's going to be 160. At least I hope it is. There it is. So again, we could either add or subtract, but I'm going to subtract 360. And I think you could probably look and know that that's going to be 200. There we are. So 200. Somebody else might have said, no, I wanted to go 160 and I wanted to add that to get a coterminal, and we're looking at 520. Again, all sorts of valid answers. I don't care which one you pick as long as it's coterminal, because it just says find one that matches. Just again, knowing the coterminal has exactly the same location. And the final question on the page, number 10. Okay, so we're going to give that coordinate, negative 5, 4, which goes over and up. Now, one of the distinctions that we have made in this class is that we always draw our triangles where one of the vertices is on the origin and one of the legs is sitting on or hanging from the x-axis. So we make sure we line that up. A quick little look at the Pythagorean Theorem. A squared is 16. B squared is 25. If we took a square root, we'd be looking at root 41. So now I have mine thoroughly labeled. Please notice that that 5 is negative because it's going to the left. The 4 is positive because it's going up. It's very important. We know that since it's in that second quadrant, I know that the sine and its buddy over here, the cosecant, are positives, but I know that everybody else better be negative. And I've noticed a lot of people make little mistakes on that. But here we go. Let's start with the sine. The sine would be 4 over root. I'm going to write it up here. The sine is opposite over hypotenuse, because our theta is right here. That's our reference angle. So we're supposed to write 4 root 41 over 41. That's kind of obnoxious. In the same way, the cosine would be negative 5 over root 41. So negative 5 over root 41. So we're going to multiply the top and bottom by root 41, like we did on the first one, to simplify it. So I don't really want to do that very frequently, but because it's going to happen. The tangent's easy. SOHCAHTOA, right? Tangent is opposite over adjacent. So opposite over adjacent is 4/5, and therefore 5/4 for the cotangent. And the secant and the cosecant, now those are the nice ones. Now remember, the cosecant is actually the reciprocal of the sine. So keep in mind, this was the sine that I found right there to start with. So if I flipped it over, I'd just get root 41 over 4. And the secant, if I flipped it over, remember this was it was 5 over root 41. So this is root 41 over 5. So that's one of the reasons I don't simplify immediately. Sometimes I write the unsimplified value so that when I go to flip it over, it's already sitting in the appropriate fashion. So that's page 1. Hopefully that was kind of the easier part of trig, because it's been a long time, but those shouldn't be too crazy. So I will see you back for page 2 soon. Okay, bye-bye.